Welcome to MEI Modelling with Algorithms. We're on the topic of Linear Programming 1, Introduction, and this is video 1.6, Linear Programming Problems in Augmented Form. So what we're going to introduce at this point is what we're going to call a standard form for presenting linear programming problems. Now, in fact, not every single linear programming problem that we've met can be written in this form, but the reason we're choosing this form is that it is the form which is expected if you're going to use what's called the simplex method, which is a very powerful algebraic way of solving linear programming problems. So what we want to try to do, if we're going to get this thing into standard form, is have our objective function as usual and then write the constraints in a form such that we have a positive number on the right hand side only, with the variables therefore on the left, and less than or equal to signs in all of the constraints. Apart of course from the constraints on the variables themselves that have to be there, which ensure that those variables are non-negative. So now we're going to introduce the idea of slack variables. Now these can be introduced anywhere where you've got an inequality representing a constraint, and what they will allow us to do, as you'll see in a moment, is turn that inequality into an equation. Now, to help us understand how these are working and what they might represent in the context of an actual problem, we're going to think of a real life problem here involving a 12-meter roll of cloth, and imagine that we're making some dresses and some skirts from that cloth. So this is a typical linear programming type of constraint. So dress needs 3 meters of cloth, skirt needs 2 meters of cloth, and we've got a maximum or a total amount of cloth available to us of 12 meters. Now to start off with, we've got the constraints which have to be there of non-negativity, and then so in the usual way we'll give variable names to, in this case, the number of dresses and the number of skirts, and then that allows us to express this constraint in the form of an algebraic inequality like that. So if we imagine what this could look like, we've got this 12-meter roll stretched out, and this is representing 2 dresses and 1 skirt. So 2 dresses will obviously need 6 meters, so that blue section there is 6 meters, and this pink section is the 1 skirt, which is 2 meters. So overall that comes to 8 meters, and of course that leaves us with what must be 4 meters of leftover cloth. And what we'll see is when we introduce these so-called slack variables, that they represent this amount of leftover material from that constraint. So what we can see now is another possibility. So obviously these things are variables, we've got some choice in what their values are. So this time we've chosen x equal to 2 and y also equal to 2, and that's allowed us to make more things, and obviously that's left us with less cloth remaining spare. But of course we can see that there is a limit, and maybe sometimes there'll be no spare cloth at all. But this amount of leftover cloth can never be negative. So in a sense we can think about this leftover amount as being another variable. Obviously it depends, its value will depend on what the other 2 variables are, but it behaves very much like them in that it has to be non-negative. So what we can do then is, instead of thinking about this inequality, what we can do instead is introduce this new variable that we'll call s, representing that leftover cloth. That's called the slack variable, and it makes up the difference between the left hand side and the right hand side of the inequality. So it's whatever I have to add to 3x plus 2y to make the number 12. So I can represent that as an equation, and the information regarding the actual inequality, this sort of boundary that we can't cross, that can be represented by including s greater than or equal to 0 with these other 2 natural constraints which are there. So all that information that's contained here is now also contained here. So this is an alternative way of expressing that information. So thinking back to the problem that we saw on the first slide, we haven't put this problem in any kind of context, but it is a typical linear programming problem, and it was written in what we call standard form. We can now see how we can convert from that standard form into what we'll call augmented form, and all we've done is the three constraints that were represented by inequalities, we now change these so that they are equations. All the numbers and the variables are the same, the coefficients are the same, but we've now got these three different slack variables added onto the left hand side of each, so that we can now replace what was an inequality sign with an equal sign. And to make sure that we keep that inequality there, we have these inequalities forcing these slack variables to be non-negative. So that was rather a short video. It's just introducing this idea of augmented form. You'll see later why this is such a useful thing to be able to do, because it's what is required when we conduct the simplex method that we'll see later. So that concludes video 1.6 and also concludes the topic Linear Programming 1 Introduction.